Okay, this video is for 11G-AR, angle relationships in regular polygons. So on the front side of this worksheet, they've given us a list of all polygons from 3 sides, which is a triangle, all the way down to 20 sides. And they want us to fill out answers to each of these polygons based on the number of sides, the interior angle sum, each interior angle measure, exterior angle sum, and each exterior angle measure, as well as the number of diagonals. So let's take a look and fill in the row for the pentagon. So a pentagon, zoom in here, a pentagon has 5 sides. Now, if we want to find the interior angle sum of a pentagon, we have a formula that we talked about earlier this week, and that formula is n minus 2 times 180. So n is the number of sides of the polygon. So since we are working with a pentagon, it has 5 sides, this becomes 5 minus 2 times 180. And 5 minus 2 times 180 is 3 times 180, which is 540 degrees. Now, if we want to know each interior angle measure, we have to take our sum, which was 540, and divide it by how many angles we have. And in a pentagon, we have 5 angles. So that will become 540 divided by 5, which equals 108. So each interior angle is 108 degrees. Now, exterior angle sum. This actually never changes, so that's pretty nice. Everywhere on this column, no matter what the shape is, it should add up to 360 as exterior angles. So this will be 360, this will be 360, and the same thing going down. That one never changes. But each exterior angle does change, and each exterior angle is going to be supplementary with the interior angle. So we'll take a look at this 108, and we know that this number, the interior angle, which is 108, plus the exterior angle has to equal 180. So that would be 180 minus 108, which equals 72. You can also find that by taking this number, 360, because all the angles have to add up to 360 on the outside, and dividing it by how many sides there are for the polygon. So 360 divided by 5 also equals 72. So either of those methods are perfect. And then finally, number of diagonals. And we talked about number of diagonals having a formula as well, and that formula is the number of sides times the number of sides minus 3, all divided by 2. So we need to plug in 5 for n since we are working with a pentagon. So 5 times 5 minus 2 divided by 2. And if you simplify that, or 5 minus 3, sorry, this top one needs to be a 3. And if you simplify that, 5 minus 3 is 2, 5 times 2 is 10, and then 10 divided by 2 is 5. So this has 5 diagonals. We'll zoom out real quick. So that's what you want to do for each of these polygons. Alright, now let's take a look at the back. Let's think about this for a second. This is very important. Each blank here is a column from your table. The columns from our table are like the headings in our table. So we'll have to put one of those things in our blanks here. So let's think about this. As the number of sides of a polygon increase, the blank, blank, and blank also increase. Now those answers are this. As the number of sides of polygon increases, the sum of the interior angles increases. The measure of each interior angle increases, and the number of diagonals increases. And as you fill out your entire table, you'll be able to see that occur as you move it down. Now, as the number of sides of a polygon increase, one thing decreases. And what decreases is the sum of each exterior angle.